All right, now moving on. Now we've been looking at only fractions that are positive. So now let's move to fractions that are negative. So with the negative fractions, one negative sign will give a fraction, make it negative, whether it's in the numerator or in the denominator or in out front. So we can place that negative many different places. So if we let a and b be integers, then all three of the following fractions are equivalent. So we can have that negative in the denominator. We can put the negative out front, or we can put the negative in the numerator. And that makes all of those fractions equal to a negative fraction of a over b, okay? Now, one thing to note is negatives in the denominator are not ideal. So usually we move it to the numerator or out in front, as shown in the second two cases. So this is usually what we want to do, but we can keep it here if we need to. But a lot of times we like to have that negative out front or that negative on top. But this is also allowed. But the normal routine is to make it look like this one. Now, recall that if we have a negative in the numerator and a negative in the denominator, what happens? Well, negative divided by negative is positive, and so we're going to get a positive fraction. So if we again let a and b be integers, then a negative a divided by negative b, those cancel, and we can just get a over b, because negative divided by negative is positive. We just get the a over b. Okay, so that's a key thing too to watch out. If you have negatives in the numerator and denominator, your overall fraction will become positive. All right, so we're back to reducing again. Okay, so we see we have a negative here, and we also have a negative here. There's only one. So we know our final fraction has to be negative. And whether we want to put that negative in the denominator out front or on top, it really doesn't matter. It's still going to be a negative fraction. So let's first factor our two numbers. And I'm not going to worry about the negative. I'm just worried about the numbers. Okay, that negative, like I said, we can put that anywhere. So it's not a matter of part of the reducing to the prime factors. So 18, well, that's divisible by 2. And 2 times 9. Well, 9 is not prime, so we have to factor that. Well, that's 3 times 3. And those are both prime. So the numerator is 2 times 3 times 3 times 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. Okay. And 45. Well, I know there's a 5 here, so I can factor out a 5. And 5 times what's 45? Well, 5 times 9. Well, okay, so we can say, well, that's 3 times 3. And so now I have 3 times 3 times 5. And then I have 4 y's. 1, 2, 3, 4. And then I have that negative somewhere. And what I'm going to do is I'm just going to say I've got the negative out in front here, so I don't have to worry about that. It's there. Now I can start canceling. Well, cancel the 3 and that 3. Well, that 3 cancels that 3. Well, then I have a y here and a y here, y here, y here, y here, y here, y here, y here. And those can't cancel. Those can't cancel. And so let's circle what we don't cancel. And so remember, that's a negative 2. Then I have a y, and a y. Down here, all I have is 5. So we now write this as a negative 2y cubed over 5. Now we could also have written it 2y cubed over a negative 5, or we could have had a negative 2y cubed over 5. Again, out front, down below, or up top. Either one of those are all the same thing. They all are equivalent, equal, and give us the same answer. It just depends on where you decide to put your negative sign. All right, so let's do the next one. Okay, so again, if you think pausing will help you and you can practice to see if you get the same answer, that would be a smart thing to do, and then start it up again and see if you got it, was what I would suggest. All right, so that's divisible by 2. So 2 goes in here what? Well, 2 goes in here, 74 goes in there, 2, that's 3, that's 6, 1, or that's subtract, that's 1, then 4, that's going to be a 7, so 34. So 2 and 34. That's not right. 2 and 37. I don't know why I wrote a 4 there. All right, that looks better. Now 37, that doesn't look to me like it's nicely divisible by anything. 2, 3, 4, 5. Yeah, that I'm betting money that that's a prime number. Okay, so means my numerator is 2 times 37 times 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. All right. Now 52. Well, 2 will go in here, and 2 will go in here twice, and then a 6. So that's going to be 26. So I have 2 and 26. Well, 26 is divisible by 2 again. That goes into 1, 3. Well, that's a prime number. So I have on the denominator 2 times 2 times 13 times, now I have 1x and then 3y's. Okay, and then I've got that negative still out front somewhere. Okay, now let's cancel. Well, that 2 will cancel. One of those x's cancel. 1y, 2y, 3y. And I think that's all I can do because there's a 37 and that. So I have a negative, a 37, and then 1, 2, 3, 4, 5, and then a y, and then a 2, and a 13. And like I said, circling them all sometimes is going to help you remember what's all left in there. So we have a negative 37. Then we have 1, 2, 3, 4, 5 x's, so x to the fifth, 1 y, all over 2 times 3, or 2 times 13, which is 26. And again, it doesn't matter, numerator, denominator are out front for your negative. I'm just going to keep it in the numerator, okay? So that's what I would have for that reduction from 74x to the 6y to the fourth over negative 52xy cubed. That comes down to this. All right, what about these? All right, well, guess what? Here we have a negative divided by a negative. So what do I know about that? Those become positive. So I don't have any negatives left. And so now I have to just find the factors of 84 and 16. Well, 16 is easy. That's 2 times 8, which is 2 times 4, which is 2 times 2. Okay. So that one was quick. So that equals 2 times 2 times 2 times 2 times x, and then times y's. Okay. Now what about 84? Okay, well, 2 will go in here, and that's going to be 42. 2 will go in here, and that's going to give us 21. 3 will go in here, and that will give us 7. And so the numerator is 2 times 2 times 3 times 7 times x, x, x times y. Now we get to have fun and cancel. All right, so 2 and 2, 2 and 2. No more 2's. Now we have 1x, 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 1x. Now 1y and 1y. And that looks to be everything. So let's circle what we have left. We have a 3, we have a 7, nothing else. We have a 2, x, and a y. Okay. All right, so what does that leave us? Well, 3 times 7 on top is 21. 2 times 2 is a 4. Then we have an x and then a y. And that is all we have. And we could erase that, but then it's going to erase the whole whole fraction bar, so we'll just leave it like that. Okay. And again, the key was doing your prime factorizations, the writing out all your variables, and then just canceling top and bottom. All right, guess what? This one again has negative divided by negative, which is positive. And so now we just do a 76 and a 57. All right, 76. Well, that's going to give us a 2. And 2 goes in here, 3. And then we have 16 left, so it's 38. And so then we can break that down. And again, it's 2. 2 go in here, 1. Then we have 9, so that's 19. And 19, that's as far as I can go. So that would be done. All right, so 2 times 2 times 19 times y times x. All right. So 57, well, what are we at? 5 and 7 is 12. That's divisible by 3. Because if you add your two terms together and it's divisible by 3, that the two added together, so 5 plus 7 is 12, divisible by 3, that works. And so now we just have to take 57 divided by 3, that goes in once, that's 3, that's 27, so that's a 9, so it looks like a 19. And we already said that was a prime, so we have 3 times 19 times 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. All right. Now we get to have fun and cancel. Well, 19 cancels 19. One y cancels one, another y cancels another, and one x cancels one x. And so what's left? Well, we have a 2, nothing else. We have a 3, 1, 2, 3 y's, and 1, 2, 3, 4, 5 x's. So on top we have 4. On the bottom we have 3y cubed x to the 5th. Okay, and that then is going to be our final value. All right, I'll stop there.